Hi everyone, welcome to my channel. This is Leo and let's do some more Leetcode problems today. Today's problem is called threesum. It is pretty similar to the classic two-sum question, and we were given an integer array nums, return all the triplets, nums I, nums j, and nums k, such that they are separate, and the sum of the three elements equals to 0. And the solution set must not contain duplicate triplets. So we have to deduplicate while we're building this solution, okay? And we're going to return all the triplets, so it's not just a number, okay? Let's take a look at the example here. We have this nums array as the input, and we're going to find three elements that sums to 0. So we can easily identify these three here. And yeah, we have something else like these two and this one, which also sums up to 0. So this will be the solution. And here, if we were given an invalid input, we will output nothing, okay? And here the answer is unique. So we have only one solution here, okay? So this can sometimes resemble the two-sum solution. And for two-sum, if you could remember, we have a classic hash map solution, and we have a follow-up, which indicates that we have a sorted array and find the two-sum. We can use 2 pointers, okay? So for this, we can use 2 pointers as well. Let's see if we have something like this. The -1, 0, 1, 2, -1, -4, and we sort it. It becomes -1, -1, 0, 1, 2, 4. Oh, sorry, it's -4. Okay, so -4 should go here. Okay. Now, if we have an I, a j, and a k here, we can also do the 2 pointers trick. We first fix the I and move the jk to see if we can form a 0. If it can, we add it to our final result and then keep moving until they interact with each other, like they intersect with each other. Then we move I forward, then move from there. Okay, so that's pretty simple and intuitive. We can code it out. I think that's enough for us to know. So we first form the solution here, and we do some corner case check. So if we don't have a nums array, or its length is less than 3, so we cannot get any result from here, okay? Yeah, next we will sort the array. And then next, we will have these 3 pointers, okay? So first I goes to -2, okay? So I goes only to the last last 3 element here, the third element to the last, okay? So it can only go from the first element to here. So that's why this is the case. And then we can assign j and k, okay? But before that, we have to do some deduplicate, okay, deduplication. So if I is larger than 0 and nums I equals 2, nums I minus 1, at this time we will just skip it, okay? And now we have j equals to I plus 1, k equals to nums dot length minus 1, okay? then we can iterate the j and k pointers. So when they don't intersect with each other, so sum equals nums j plus nums k. And we know, since we have a sorted array, if the sum plus nums j is larger than 0, we will decrement k by 1. Okay, so else if sum plus nums I is less than 0, that means we are going to increment our left boundary. So j plus plus. Else, at this branch, we have a solution. So we add it to our final result. As list, we have nums I, nums j, and nums k. Okay, and then once we have a solution, we will iterate from the next point of j. Okay, so that involves another deduplication. Okay, so let's first increment the j pointer, and then while j is less than k and nums j is equal to nums j minus 1. In this case, we will move j to the right. Okay, and return result. Okay, let's walk through the code again. That's the corner case check. We sorted. We initialize the first pointer, the second and third pointer while they don't intersect. We have the sum of these two elements, and we add it with the nums I. If it's too large, we will decrement the right side, and if it's too small, we will increment from the left side. And else, we have an answer, we add it to the final result, and then we continue with the searching. Okay, so that should be all right. Yeah, looks like it's passing all the test cases. Let's analyze the complexity. So for time, we have a for loop here, so that's n, and we have another while loop here, so the time complexity should be n squared. We also have a n log n here, but I don't think it will be predominant. So the predominant will be n squared. And for space, we have the sorting, and we have the result, but the final result shouldn't be counted as extra space, so we only have the sorting. So that's going to be log n to on, depending on the sorting algorithms you have. Okay, great. Thank you so much for watching. I will see you in our next video, and if you like the video, please like and subscribe to my channel. See you later.